quite possibly the most important rule in all of calculus, the chain rule. But first of all, what is the chain rule exactly? In order for someone to understand the vital essence of what the chain rule is, one must actually know the formal definition of the chain rule to begin with, which goes like this. If g is differentiable at point x, and f is differentiable at the function g of x, then the composite function capital F equals f of g, which is defined by the function capital F of x equals f of g of x, is differentiable at point x, and f is given by the product capital F prime of x equals f prime g of x times g prime of x. Now that we know what the chain rule is and what it consists of, next is to know when to actually use it. In order for one to properly use the chain rule, one function's differentiation must be inside of another function, as shown by f of g of x. A couple examples of this are functions that include square roots, exponents, or exponential functions. Now that we've gone over the chain rule and all of its parts, now let's go over each individual piece of the chain rule. We have f, which is the outer function, g of x, which is the inner function, f prime, which is the derivative of the outer function, g of x, which is the inner function again, and g prime of x, which is the derivative of the inner function. The template shown below shows where each individual piece goes. Now that we know what the chain rule is and when to use it, let us look at some examples. Our first one being 3x plus 1 to the quantity squared. Our first f equals g to the x squared. Our g to the x is 3x plus 1. Our f prime is 2g to the x. Our inside function, g to the x, is 3x plus 1 again, and then our g prime of x equals 3. So we start off by plugging in our individual pieces to our template. The first one being f prime times our g of x function times g prime of x, which gives us 6 times 3x plus 1. Distribute the 6, it gives us 18x plus 6. There's your answer. Our next example is going to be a little tougher because it has a trigonomic function this time. We're trying to differentiate the sine of 5x squared. Thinking about our individual pieces again, we have our f function, which is the sine of g of x, our g of x function, which is 5x squared, our f prime equals cosine of g of x, our g of x function again is 5x squared, and then our g prime of x equals 10x. Thinking about our template again, we have our f prime function on the outside, which is the cosine of the inside function, g of x, which is 5x squared, times by the g prime of x function equals 10 times 10x, and that's our answer because we can't reduce it anymore.